Welcome. I'm Ross Young, and I'm here with G. Mark Hardy, and we are both excited to share with you CISO Tradecraft. CISO Tradecraft is a podcast which discusses how to navigate people, processes, technologies, and environmental issues within the information security industry. The show focuses on mentoring the next generation of cyber leaders take information security skills to an executive level. With that, we are excited to take you to today's show.
And hello, and welcome back for another episode of CISO Tradecraft, the podcast that gives you the tool sets to be successful in your career as a CISO or somebody working your way up in the career chain. Today, Ross and I would like to talk about a concept with respect to modern software development best practices. Okay, what and why does a CISO need to know about software development practices? And then we're going to get into some specific details, including something called 12 factors. So, Ross, what are our thoughts? Why does a CISO really need to know about this stuff?
Well, I think there's two reasons we need to think about this concept of modern software development. The first is there's developers in most organizations. And as the CISO, you're responsible for secure software development practices, right? So you need to understand how they're making software so you can fix the processes that might be bad and ultimately cause harm when bad code is deployed for the company. The other piece that most people don't think about is you may have software developers within the cyber organization. And that's where you really have to make sure someone who reports to you is making sure that they're building software in an effective way that is going to produce software faster. It's going to produce better software that you can rely on as a CISO.
I see. So, really, what we have then is a couple domains, if you will. The internal domain to security, which says we need to write some apps, we need to build something that's going to give us the tool sets we need to effectively administer our enterprise security. And then also, if you will, perhaps an influence role on the app developers throughout the organization, although probably few, if any of them, will directly report up through the CISO. Nonetheless, our responsibilities to the organization are to ensure that that development is done in a risk controlled manner. Am I
You
saying
got
that
it.
about right? Okay, got it. Well, any great tools or concepts that we should talk about? I know we've heard a few, and there's one in particular that you particularly like.
Yeah, I really like something called the 12 factor application or the 12 factor app. And really, it's about how do we build software in a modern way using 12 common practices that really make modern software. So I'm excited to share this with everyone.
Yeah, and I think if anybody would like to get a little bit more detail, you can find a source document at 12factor.net, 12factor.net. So let's dive in. And the first of the 12 factors is the code base. And the idea of having one code base tracked in revision code with many deploys. Thoughts on that?
Yeah. So what we see is organizations moving to a common repository, also known as Git, GIT. And you'll see a lot of organizations use something like GitHub or GitLab or any other tool that really provides a way to track software in a repeatable fashion. And the focus here is if there's multiple code bases, it's a distributed system. It's not just a single application. We want to have one place where we can go in to learn about the code. We want to have one place to go in where we can say, here's the 5 people who can have access to this code, this intellectual property for our organization. And when we have this in disparate places, it's really, really hard to manage. And if somebody says, well, what percentage of your applications have this library with known vulnerabilities, and you got to scan 10 different locations, that's really complicated, right? But if all we have to do is scan GitHub as our one source code repository, it makes it much easier for us to respond to incidents.
Now, I get that, but here's another thing from time to time I hear in the press that GitHub is breached or somebody has scanned GitHub and found embedded passwords. Is GitHub really a security solution that helps us? I can get it that it gives us revision control, but is it worth the risk of putting your code out there where anybody can get it? Or Could it be done properly such that GitHub is then a secure repository?
So, what you mentioned there is there's open source software where people upload to github.com or gitlab.com and share their software. And that can be a really good thing to promote reuse of your software to get more people to develop and add features to it. But you never want to put sensitive data in public locations, right? So if you're storing passwords to your AWS environment on a public location, well, it makes it really easy for people to come into your AWS environment. So don't do that. If you're storing your database of data, your passwords, your credentials, or anything sensitive, that would be another misconfiguration, right? This should only have code. And once again, consider code as intellectual property. Only the folks who need access to it should have access to it. If it's something that you're open sourcing and sharing, makes sense. If it's something that's private and is really sensitive, you may want to lock that down to only the people on the app team, not just folks within your organization.
Sure. And so then what happens then is these code repositories don't have to be up on the internet. They can be maintained locally, they can be maintained securely. The point is, in having a single repository, we're able to go ahead and keep all of our code aligned instead of having a little bit here, a little bit there, and stuff all over the place.
That's right.
All right. Number two, dependencies. Things that our software is going to rely upon in terms of an external library, for example. The requirement here is that the dependencies be explicitly declared and isolated. And can you give me some examples of that and what that might mean?
Yeah, so let's just take the example of Java. When people write a Java web application, they're using tools like Maven or Gradle to essentially declare what files are included in it, right? They didn't write the entire app from scratch. They use libraries from open source to provide a front end UI, to provide calls, provide language packs, all these little things that make their app. And normally it's about 70% of an app is from open source tools, right? So when we have all of those things, we need to understand, are those external libraries we're including vulnerable? Maybe there's old versions that have vulnerabilities in them that we can check. The other thing is, even if they're not known to be vulnerable, are they the latest releases or maybe one version behind in the last stable release from a developer? So, what developers will do is they'll use Maven to create a Maven file or a .pom file, which is a project object model, which declares the exact versions of libraries that they're inheriting. And by doing this, you can run simple tools like Maven versions, which would say, list out the libraries you're using and let me know if those are the right versions of software. Because if they're not, maybe the developer made 3, 4 releases that you haven't updated, and there's memory leaks, which is why he made the releases. And so using this allows a developer to really understand all of the pieces inside their application and use that to promote better code that has more fixes and less bugs in it.
Got it. So these dependencies then are external libraries, as you indicated. Yeah, no one's going to want to write everything from scratch if somebody has already put together an improved routine to do something, such as, let's say, I need an AES 256 encryption. But we want to make sure then that we're capturing or including those pieces of code that are known to be correct, that we don't just kind of randomly grab something and introduce some problems to our environment. Number three is configurations or config. And if we look at the 12 factors, the idea is to store the configuration within the environment. Now, what are the alternatives to storing those configurations in the environment, and why are they bad? And why is this a better approach?
So if you store configurations within the application source code, then that means you have to write 5 different applications for each of your different environments, right? If
Mm.
you have a dev environment and you say, here's the IP addresses to go to, well, that's statically tied to that. And guess what? When you now run it on your prod environment, it doesn't work. So the idea is, how can you have variables inside your app that say, okay, I'm going to take in this external input when it runs the app to first initialize. And you might say something like, okay, here's where you're going to get the IP addresses, here's the network you're on, here's maybe some keys or other things that may have to be passed into that application to run. And this allows you not to have to store, things that could be more sensitive, right? If you're storing your password inside your code, that's not a good thing.
Yeah.
But if you're just storing a variable and it just says, name a variable, there's not a lot an attacker can do with that comparatively, right?
Right. So then we have then is the goal is that this external environment, like an environment variable, is going to contain these things that we need to have. I can remember as a developer years ago when we are first trying to change things, I think it was from English to Spanish, and all the English phrases were hard coded into the code. Now, granted, this is a lot of years ago. It meant going back through and picking through every single line and changing it, as compared to, if I'm getting the analogy right, having an external file that says, hey, what language do you want? And if you are using English, then here are the 100 different things to display. And if it's Spanish, here are the 100 things to display. And they're all external. But this could be done without ever having to change the code.
Yeah, yeah, I think that's spot on. Another key piece here is by performing this, we can really make sure that everything is signed, hashed for our applications, right? So our code doesn't need to change. The only thing that's changing are the external variables, right, outside of the environment. And by doing this, we can have signed code, we can have signed containers, and we can run them in a read only mode. And then if anything in the app changes, something is wrong with your environment. It's a really good way to ensuring that this environment stays static.
Hmm. Excellent. All right, great. So we're starting to home in on some really useful things here for the developers. And again, as a CISO, to understand these principles, I think are key because now you can assess your risk by determining how many of these are actually being utilized in your environment and potentially reduce your risk by introducing your dev team to these. The fourth of our 12 steps is backing services and treating those as attached resources. So, I suppose the first question is let's define what a backing service is for people who don't understand that. And then we'll talk about why it's important to treat them as an attached resource.
So, if we think about our application not really changing, it's this read only source code, then we have to have somewhere to store the information that we want to save, right? If a user goes into our website and he changes these fields, we need to save those things to some type of storage, right? This could be an Amazon S3 bucket. This could be a database that we'd put it in. This could be an external API that we're calling and sending data to. So that's what a backend service for an application is.
Okay. And now, when we're treating them as an attached resource, how does that give us some advantage in terms of risk reduction?
I think the advantage here is you can switch them out very quickly, right? So if you have one database and you can point it instead to maybe like a load balancer that has multiple databases behind it, it allows you to have a little bit higher distributed network where your system will be able to handle DDoS attacks a little bit cleaner. So just by having the ability to just statically show what connects to it and being able to swap those in and out whenever you need really allows this backing service to be much more ephemeral in nature, which is really where we're seeing software going.
Okay, so what we have then is essentially our code is no longer going to be, if you will, hard coded to some particular, in this case, a data source, like a database or something like that. But rather you could say, hey, I want to swap out from a pointer to my local database to one up on Amazon. And so really what I need is some sort of invariant element of the code, correct?
Yeah, and think about it this way. Perhaps your organization has been paying for a database that is very expensive,
Hmm.
and it's a common database, and suddenly Amazon has an identical database without the licensing fees, which are very expensive. Could you switch from this paid for database to this other database if they're both the same kind and greatly reduce your licensing costs very quickly?
Yeah, and that sounds like a real opportunity. And so if we plan accordingly, we're able to then have that flexibility and can adapt as needed. Got it. Okay, so we've covered Codebase, dependencies, config, and backing service. Number five is the stages of build, release, and run, and they should be strictly separated. Let's talk about that for a moment.
Yeah, so there's different networks that organizations are going to have. You're going to have a build network, also known as a dev network, where developers are going to be trying things, which means it's not a hardened app. It's a quick proof of concept to make sure things work. And it may be the next release of your product that you're really focusing on here. And so in this build stage, it's where we're transforming our code into an executable that we can then, let's say, release. Right. So it's committing code to source code. It's looking at that environment where everything can change very, very dynamically. The release stage is that second piece. Okay, we've taken our app and we've created an executable, if you will, or just a jar file that has everything that we need to release in the next version of the software. Well, now that we have that, we need to make sure it's staged for deployment. We need to do any of our quality assurance tests to make sure it passes our specs before we just introduce it into our environment. And so it's really all about staging. And then last but not least is the run stage. This is where we're taking it and putting it into execution, right? So it's being deployed and how it's managed. So they really like to split out the code from the building from the releasing stage, if you will.
Now, that sounds a lot like DevOps to me. Are we basically in violent agreement and saying the same thing with just different terminology?
Yeah, so DevOps goes hand in hand with this 12-factor app. They're using many of the same best practices here. The idea being, how do I make sure when I build something on my laptop, it actually runs on my AWS production environment? Because if every time I change environments, I have a lot of rework, that sucks for any developer, right? Nobody wants to do that. They want to build it one time, they want it to work same, and minimize the amount of rework that they have to do.
Got it. And as a result, then, this really becomes a criteria in our software development lifecycle process or approach to say we do the separate build, release, run stages, which allows us then to not have them bleed over, and therefore you're constantly, if you will, not having a good, clean pass through in my SDLC.
Exactly. And also from a security perspective, we want to think about how we want things to look. Right. So for your dev environment, it can be open, it can be vulnerable, it can have, a lot of things because they're just building all the time in there.
Mhm.
But there's no real production data, so you're not too worried. And when I say open, I don't mean open to the internet. Just a clarification on that point. Now your QA environment should look just like your real run environment, right? And this environment will allow you to know, does your system have stability? But maybe your QA doesn't have real production data. It only has test data to simulate it. So once again, you're not as worried about that. Versus your prod environment is where the data lives, right? So you have to have all your security controls there because that's where you can lose your data, right?
Yep, exactly. And we have heard scary stories in the past of production data working its way into a test environment. Oh, it's only test data to be fully compromised because nobody bothered to protect it. Let's take a look at number six then, the concept of processes. And what we want to do is execute our apps as one or more stateless processes. So I guess the first question is, of course, most of us kind of know, but what is stateless for those who need a little quick review? And then how do we execute our apps as one or more stateless processes?
So, stateless means the data is not stored within the application. Just like we mentioned before, that you may want to store your data outside of the application in a share drive, in a database. And by doing this, what it means is you can restart the application all the time and you didn't lose data. Now, compare this with the stateful data. Okay, a developer logs into the server, changes all these environment variables, has the database storing data within the app, not external to the app. Well, now if something is wrong with this system and they have to restart it, it's a bear, right? Because you got to go through all those steps again to make sure it was configured exactly the way that person manually changed everything. Hey, guess what? Did you actually take a copy of the data from the last time it went bad? Or did you lose records from your database, right? So you can quickly see why having your data outside is really powerful. And the other piece is if you're able to do this, you can make your application as read only. And this is a really powerful concept in terms of security. Think about it this way. If a file is read only, it's really hard to change the permissions around it. But if a attacker has the ability to do a buffer overflow into your system, and now he can start to write to things, well, that would be really bad. But if he tries to write to something and overall the app has read only permissions, it doesn't work, right? So it's a security feature too to make your application stateless and store your data in the databases external to the app.
Got it. Yeah, I remember years ago when back in the 90s when hacking websites was all the rage. Of course, today people hack websites to inject ransomware, but back then it was just shout out greets to my hacker buds. And all these government agencies got compromised. And I think that ultimately they finally got the White House. It was a server farm over in Northern Virginia. They got like a FTP password. But there was one agency that never, ever, ever got hacked. And it was the National Security Agency. And I remember talking to somebody at a conference a few years later about at NSA, said, how did you guys manage to never, ever get hacked? And they said it was real simple. Every time we spun up a new version of our website, we put it on a CD and we ran it off of a CD, and we didn't have a CDR drive. We just had a CD drive. It couldn't write to it. So literally it could not be altered. What we're saying now in a little bit more modern methodology is that an advantage to having a stateless process, HTTP, for example, is stateless. Every time you go to a website, it doesn't know where you are. That's why we have cookies. In the same way, we execute our processes that way, allowing us to be read only, have a nice clean start, if you will, and do a better job, I think, overall from a security perspective. That sounds like a really great item. We're on to number 7, port binding. And we're going to export services via port binding. So let's talk about that and see what does that mean?
So sometimes web applications are executed inside a web container. For example, PHP applications might run inside Apache HTTP daemon, or Java apps might run inside a Tomcat. So what we're saying here is an application should be self-contained and not rely on runtime injection of a web server to make it internet facing. What I mean by that in a very modern, let's say, simple thing is it needs to have a static place to go. It should say localhost port X, right? A specific IP address could also work just well. This allows it a standardized way where people can talk to it, right? So that it's very consistent and you only have to expose what you need in a consistent way.
So really what this would be then is, are we talking about the admin interface with an app as compared to the user interface? I mean, typically a user, if it's a web app, it's going to be 80 and 443, and it's pretty much your limited choices there. Um, but here, what I think we're doing is that we're talking about having everything not relying upon some change in the execution environment to create a web-facing service. But we've already decided, hey, we know what we're going to listen into, and we're going to build this right into our application. Is that a kind of a good summary of it?
Yeah, what we're talking about here with port binding is making sure that one application can become a service for another. It's static. The only way to talk to this app is through this location and this port. And it really allows one application to connect to another in a very consistent way as it's declared through the configurations of the app.
Got it. And so therefore, you don't have to worry about things arbitrarily crashing in the future because, well, it's not where it was supposed to be. Well, it's got to be there because the way we built it that way, there's no variability in there. It gives us a nice, consistent, um, I guess, performance, I suppose, in the long run.
Exactly.
Number 8, concurrency. All right. We're going to scale out. Applications are going to scale out via the process model. So what are we talking about here in terms of scaling out via the process model?
So, what I think we're talking about is each thing is its own process. So instead of having one thing that does everything, how do you almost take this micro segmentation approach where you have a service for this web application one and web application two? And how can you use things like containers that allow multiple things to be running in one location on one larger server. So this really is very powerful. I mean, it's taking a lot of execution forms. For example, PHP processes could run as a process of Apache, right? And Java can take an opposite approach where the Java virtual machine provides one massive Uber process that runs all the CPU, all the memory. And in here, what you're doing is you're making sure each of these gets the resources that they need from the daemons that host these services.
Now, that probably gives us performance improvements in terms of amount of memory needed, particularly if you said we've got one environment where everything provides it. Um, for those who aren't familiar with the Unix process model, maybe we can go a little bit more into that because there are articles on the Unix process model going back 20 or more years.
Yeah, so the process model really shines when it comes to scaling, right? They share nothing horizontally, uh, which means that they're adding more and more concurrency, and this type of process is known as a process formation. So imagine you have running processes that can scale going up, as well as having process types that can go to the right. So you can host two web applications on one server. You can host five worker nodes on one server, in addition to different processes that may do ETL jobs or sending data to external logs, and this allows the app processes to never uh, daemonize or write the process files. Instead, it's relying on the operating system manager, like a system D, to manage the output streams, responding to crash and handling restarts and shutdowns, which really provides a stronger resilience for your applications.
Great, which kind of brings us to point number 9, disposability, fast startups and graceful shutdowns. We're talking about a process being disposable. What do we mean by that? Is it throwaway code, or is there a little bit better definition than that?
Because we're storing the data external to the app itself is really meaningless in many ways. You don't care about any of the data in it because it's stateful, right? So this means if
Right?
it
Yeah, stateless. Did you
it's
say?
stateless. Oh, I said the wrong one there. Uh, so so this means here that what we can do is we can change things within the app very quickly. So maybe if our app relies on this open source library 1.0, which is known to be vulnerable, and we go to version 2.0 and we change that quickly within the configuration of the app, then we can just deploy that very quickly. And we can just throw away the older app because the data didn't get lost. So it's about maximizing the robustness with a fast startup and graceful shutdown. We're treating our applications as cattle, right? We care about the herd and being able to quickly upgrade fairly quickly. And it's not like we're manually logging in and nursing these pets back to life, right? We're taking this cattle versus pet approach now.
Yeah, I remember when we used to talk about infrastructure as code and treating everything as cattle, not pets. And when people say, "What does that mean?" And I said, "Well, for the most part, anybody who ever had a hamburger never bothered to ask the name of where it came from. But with regard to your pets, they're unique, and more precisely, the difficulty with having all these unique processes out there, and all the difficulty in changing it just adds a whole lot of extra time for that. And so therefore, we minimize your startup time on the processes. If there's sudden death, if a process ends, you can recreate it and not lose where you're at. As we were talking a little bit earlier about being able to, for example, storing information and configuration. I think it was way back at number three. What was occurring to me at that time, I was thinking, yeah, have you ever worked on a long document without autosave turned on and all of a sudden something went wrong? And like, oh man, I lost all that data. We learn pretty quickly. Well, now we have ways to make sure that we don't, if you will, lose what we're doing. And disposability, allowing us to rapidly replace pieces of code, gives us better code config changes, and deployment helps out a lot. All right, we're on number 10, development and production parity, or dev prod parity. We want to keep our dev environment, our staging environment, and our production environment as similar as possible. Wow, what are we talking about? And what's the advantage there?
So historically, there's been substantial gaps between development and production. What I mean by that is maybe the developer goes in and makes edits to his local deployment of the app, and then the production is running a production deploy accessed by the end users. And these gaps can be gaps that really change your app so that you don't know what's really running in prod if it's very different from dev, right? And that means you won't understand why the app is breaking. So we have things of a time gap where a developer may work on code that takes days, weeks, or months to go in production. There's a personnel gap between the folks who write the code and the operations teams that deploy it. And then there's a tools gap, right? So developers may be using a stack like Nginx, while the production app may use Apache. So if their two environments are different, that's just going to cause all sorts of issues. So it's really about making it same, and the only thing you have to do is those environmental variables that we're changing on the external piece.
So this sounds an awful lot like DevOps. And again, are we just refactoring DevOps in a different way, or this just happened to be like a Venn diagram where you get some overlaps of best practices in these two different schools of thought?
Yeah, so I think there is a strong overlap with this. DevOps is taking the best practices that it's seeing from developers, and this is another core concept of DevOps that's in the 12 factor app.
Got it. All right, the next one, number 11, are logs. And our logs should be treated as event streams. What do we mean by that? What are we trying to say here?
So logs provide visibility into the application, right? And historically they were written to something called a log file that's stored on your machine.
Hmm.
But if you remember, we're trying to make our application not store anything with it. It needs to store it externally. And better yet, how about instead of externally storing one giant log file, what if we're always streaming the logs in real time so that the security operations center gets real time threat reporting? right? So that's what we're talking about. It's being able to identify specific events in the past. It's being able to look at these trends and and alerts that come from these things. But rather than storing it in the app, how do we create a centralized log management tool for an enterprise that everybody ships their logs to? And then you get more powerful tools versus hundreds of developer teams having to create a log management tool within their internal app.
Got it. So, if you will, setting up syslog or something like that, and then just allowing that to then be UDP'd out to some log collector or a SIM, or in an extreme case, if you've got the resources, a SOC that's keeping an eye on everything, then allows us to not have the logs go away when something goes down. And we pretty much have got the telemetry right up to the point of any potential failure. Would that be true?
Yeah, yeah. So we're talking about this that folks are not attempting to write to logs. Instead, they're sending to standard out and streaming the data. I think you got it.
And so we're not going to be in the business of collecting local logs anymore. Now, of course, you want to make sure there's somebody listening in on the other end of that, or they're just going to go off into dev null. But the point is, if we use that as an architectural approach, we also don't have to worry about the reverse, which is somebody feels an app, something goes wrong, and we go, well, where's the telemetry? Oh, I don't know. It all went down the hill with the app. We don't want that happening.
And if you think about it from a security perspective, if the logs are always being sent out in real time, this makes it harder for insiders to commit fraud because they can't just manually edit the logs on the server that they control, right? It's already being sent out.
Wahaha. I love it. Okay, we are now at number 12. Let me kind of do a kind of a quick recap. I feel like Casey Case have been counting down the 12 factors. Number one was Codebase. Number two is dependencies. Number three is config, storing it in the environment. Number four, backing services, treating them as attached resources. Number five, strictly separating the build, release, and run stages. Number six, executing the app as a stateless process. Number seven, exporter services via port binding. Number eight, use our concurrency to scale out the process model or via the process model. Number nine, disposability, have fast startup, graceful shutdown, and robust code. Number 10, keep the development, staging, and production environments as similar as possible. Number 11, treating logs as event streams. So we're now off to number 12, admin processes. And admin and management tasks should be run as a one off process. What's our advantage there?
Yeah. So historically, what we saw was developers would leave certain ports open on servers so that they could log into these servers and manage them in a oh crap moment. I need to figure out what's going on. And they would leave SSH or remote desktop open. But the problem with this is really it's not optimal, right? There's got to be a way where you can maintain hundreds of servers without having to log in.
Hmm.
So what we're talking about here is how do we make all of our admin needs into code? Where maybe developers are running a tool like Chef or Puppet, which manages the system, and so they can write a simple code in there that says, "Hey, what processes are running or how's the memory right now?" And they write that as code and they can just say, "Okay, I need to run this Puppet or Chef job and execute." And then it comes back and now you know. And this is really good because you don't lose all that developer knowledge because you made it in a code.
Right. So if you have somebody who's been working on your code base for a while and has all these little tricks and tips and ways of sampling and checking, you don't want that to go out the door when that person takes another job, but rather the fact that they've reduced all of that to a code base that we allow then that to persist gives us the opportunity to have that, if you will, corporate knowledge retained with us, as well as make it fully repeatable.
So, in addition to the 12 factor app, I just want to talk about a couple of things that we're seeing software developers do now that are really valuable. The first is called extreme programming. And what we mean by that is there's really two pieces. One, how can we do pair programming where we have two developers working at the same time? This is a good way to mentor a junior employee as he learns it. And also by having two eyes, or should say four eyes on the same piece of code, then you're less likely to make mistakes.
And I've worked in that environment before, and you're right, because although somebody's typing away and walking says like, "Hey, Ross, look, you missed that." "Oh, yeah." And what the advantage of it, although some people say, "Wait a minute, that's horribly inefficient. You're paying double salaries for the same bit of code." You make it up in spades with regard to the amount of reduction of rework and errors that push to production, because these are all caught at the earliest possible stages.
The other piece of extreme programming is known as test driven development. That means before you write a new function, you write a little test case that says this fails. And then only after your function is written will the test case actually implement and work. And so this is a really good way to know that if your application ever stops working because you pushed out a new version of software and it just doesn't work, you now get feedback to know that it's broken.
hmm And there's other things we can do in extreme programming, like waiting and delaying some of these architectural decisions to what they call the last responsible moment. Now, this is not an excuse for procrastination, but expect requirement changes as customers and bosses always do change. Communicate frequently. And again, nice, small, frequent releases, sort of like an agile environment where you bound your code changes to a immediate or soon to be immediate feedback rather than going off to Santa's workshop for 6 months working on code only to come back and found out, hey, well, you did what we said, but not what we meant.
The other piece that I really want to talk about is something called user centered design. And if you've never heard of it, it's really about using powerful tools that show pictures of what the software is going to look like before it happens. And you'll see things called wireframes. Think about it this way: if I can build a wireframe or a mock up of what the web application is going to look like in 2 hours versus it takes me 40 hours to build it, and it's the wrong web application look for your client, would you rather have wasted 2 hours or 40 hours? Right? So
Obviously,
that's
neither, but you're better off with the two.
So that's what we're talking about. How can we get a quick mock up, show the client, say, hey, if I built you this, would you be happy? And then if they say, yeah, that looks fantastic, then you spend the hours to actually program and build it out. So that's a really powerful way of taking user feedback very quickly.
Yeah, and when I had done some software development with a startup a few years ago, we used something called Balsamiq, Balsamiq, which was a tool, and they advertised life's too short for bad software, so they allow you to go ahead and build the wireframes. And it's absolutely great. You can go ahead and lay things out in advance, say, "Hey, this is what we're going to be doing," and someone looks and goes, "Well, no, I want this, that." Like, great, super easy to fix, and yeah, tools like this are very easy to utilize.
So, hopefully, these two concepts of user centered design and extreme programming resonate with you. There's a lot of other topics and concepts from DevOps or lean product management that can be included, but we felt these were some of the most important things that you knew in addition to the 12 factor app if you're going to increase your CISO tradecraft.
Right. So at this point in time, we're hoping that you've got a little bit better knowledge base to be able to look into not only the apps being developed in your security team, but those perhaps within your organization. You've got some tools by which you can measure their effectiveness in terms of helping to reduce your risk by using things such as the 12 factors and apps following those. Also, techniques like extreme programming, which could potentially drive down cost in the long run, and the user centered design, being able to go ahead and build things out with the user in mind, but get their feedback early before you start coding. All these give you a much better chance of being successful in your security leadership role. You're aligning with the business, you're providing some insight and some wisdom, which is really going to help out. Any last thoughts, Ross, before we wrap up?
No, I think this is it. Hopefully, folks understand that a CISO work doesn't just stop at cybersecurity. It also needs to understand other parts of the business. And IT and software development is one of those parts. So take an interest in this because if you can fix things up front, it's going to be worth its spades on the back end.
Exactly. Well, everyone, thank you for taking the time and investing your professional time in learning CISO tradecraft. We encourage you, if you've not done so already, to subscribe and please pass it along to others. Other people will appreciate the fact that you've given them a little tip in terms of a resource that we hope is an excellent way to get better at your job. So until next time, thank you very much and stay safe out there.